All right, so welcome to class 1 of Stat 1. So, most of the professors I've ever had or I've ever heard talk about statistics, the very first class, they go on and on and on about some sort of definition as to what statistics is. That's boring beyond belief. And if you want to do that, go to Wikipedia and type in statistics if you want to read some sort of long, boring definition. We're not going to do that at all because remember, this class is a lot of hands-on, real-world type stuff. So the idea is I'm just going to dive right into it. By the end of the semester, you'll all know what statistics is. So I don't have to sit there and tell you what it is because you'll know what it is by the end of the semester. So where do we start? Let's go back into the 90s, back before there's computers. I mean, there's computers, but like no internet that people used on a regular basis. The computers were a luxury as opposed to everyone in the world had one. And let's imagine I'm walking into a company to do some consulting for them. I'd walk in, I'd meet whoever it is I'm working for. They would usually, at that point, take a huge stack of tractor-fed paper and go and plop it down on the table. At that point, I would then go and take that home or take it to my office and actually do something with it. So what did I usually do first? Well, the first thing is to get an idea of what that is in the paper. And I call this my data blob, which is this thing. I just put a bunch of dots up here. So I have this blob of data. And I have to know some things about it, right? I have to have an idea of how big is this blob. Is it really spread out? Or is it real tightly compressed? Where's the center of it? Is the center like right here? Or is it over here someplace? What's the shape of this blob? If I'm looking specifically at this one point, where is it in relation to the rest of the blob? Where is it in relation to the center of the blob? Where is it in relation to this point right here? So we have this blob and we have to understand it. And last but not least, how do we make a picture out of this thing? So that's all section 1 of what we're doing. Today, we're going to figure out where the center of the blob is. Next class, we're going to talk about how spread out the blob is. And throughout the rest of the section, we're going to talk about where each point is relative to the other points, the shape of the blob, and finally at the end, how do we actually make a picture of the blob. And when we do the pictures of the blob, nowadays, anyone can use Excel. It takes like a 4-year-old can click a button in Excel and make an amazing 3-dimensional graph. We're not going to do that at all because all of you are completely capable of doing that. Instead, we're going to learn 2 methods of how to do it by hand. I call these Perkins techniques. Because when I used to work for the U.S. Olympic Committee, my boss would drag me into Perkins first thing in the morning on a regular basis to have meetings over breakfast. Well, back then, laptops were virtually unheard of. I had one, but the battery life was like 10 minutes, so it wasn't practical to bring it. And he would always bring data and expect me to do something with it at Perkins for breakfast. It was for the U.S. Olympic Committee, so it was all data on athletes. So if I could do whatever it was that I had to do on a Perkins napkin with a pen, then it passed it was a Perkins technique. So we're going to learn 2 ways of putting a picture to the blob on, not really on a napkin, but on a piece of paper by hand. The rest of the ways, we just use Excel, and we'll talk about that later on the end of the semester. So today, we're going to talk about averages. Center of the blob. Where is the center of the blob? So where is the center of the blob and how do we find it? So an average is any one of several measures designed to reveal the central tendency of a collection of data. In other words, where is the center? If this table is my blob, where is the center of it? Well, sometimes that might be easy, right? We can kind of look at it, symmetrical. It's a rectangle, so it's right here. Sometimes it might not be so easy. So we have several different ways of doing this. And these are called measures of central tendency, by the way. And that's a value intended to indicate the center of the scores. That's kind of stat babble-ish, so we'll just call it an average. Now the interesting thing is this. If when you walked in and I said to you, okay, I want you to tell me what the average age of the people that are in this classroom is, most of you would simply go ask every single person, how old are you? That you'd add them all up and divide by the total number of people you asked. Right? That's an average. Well, that's actually called the mean, and it is only one of quite a few averages. A lot of times they talk about statisticians lying or bending the truth a lot, and it's true. There's certain types of companies I won't work for anymore just because I will not bend the truth for them. So if you read in the newspaper, not that the newspaper is doing this, but just think about it for a second. If you read in the newspaper and it says the average selling price of a house in the town of Pittsford is $220,000, all of you, when you read that, or most of you, are going to assume that they are telling you what the mean is. If they use the word average and not the word mean, it might not be the mean. It could be something else. It could be another average. So in this class, we're going to do 4 averages: mean, median, mode, and mid-range. There are more than that. We're only covering those 4. All right, before we start, let me put this up. When I teach classes, a lot of times we'll have extra credit. In other words, I'll ask a question, and if someone gets the answer, I give them, like points, a point on the next exam. So we're going to start with that today, and we're going to introduce what we're going to be doing in class. See, this is why I don't write on the board, because I can't write. When I grew up in a very, very small town in Wayne County, which is, a ways away, not that far away, but everyone in the town in elementary school that went to elementary school was required to be right-handed. If you were left-handed, you were forced to be right-handed. There were no left-handed students. And so because of that, guess what? I was supposed to be left-handed. So I am now right-handed, which means I can't write where it means. So that's why I do everything on the overheads. What kind of animal leaves that track? Yes? A bear. No. Do you guys remember Montana Mills Bread Company? Anyone? It was around here a while ago. They used to sell bear claws. They were the most amazing things to eat in the world. They're probably like 2,000 calories in one. And they had a cool track for a logo, and the funny thing is, it wasn't a bear track. I think they would have done a little research on it. Anyone else? This isn't kindergarten. You don't have to raise your hands.
Tiger?
What?
Tiger?
Okay, let's think America here. No, not a tiger. And it's not a cat either. I'm going to have to edit this out, this long pause off the video.
The dog?
Oh, who said that?
Do I get a point? I get a point?
Yes. Okay, so this is how it works. On your first exam, you write +1 on the top, and then the word dog. So I know you got the dog point. Now, but unfortunately, you get to answer a lot of questions at this point. How do you know that's a dog and not a cat? Okay, anyone know why? This doesn't count as a point, but anyone know how you know it's a dog and not a cat? Yes? Yeah, no. Okay, cats, if you own a cat, when they walk, their nails are retracted. The only time they extend their nails is when they need to climb onto something. So if there's a track along the ground and it's a level surface, there will be no indication of nails or the claws because they retract. Unless it's slipping, you won't see those. So this is a dog. All right. Next question. Domestic or a wild dog?
Domestic.
Yes! Very good. And you know that because? All right, domestic dogs, a wild dog's inner toes will never be longer than its outer toes. So this has to be be a domestic dog. So notice that these two center toes are longer than the outer toes. A wild dog's outer toes will be longer than the inner toes, or all four will be exactly the same length. All right.